Hello, good morning. Assalamu alaikum, dear students. Dear students, here I am again with the interesting topic kinematics. A very interesting graph is here. It is from June 2013, variant 1-3, question number 8. Okay, so it says that at time t equal to 0, the body moves from rest with some constant acceleration. Just note this point. Constant acceleration, it means that it is indicating some sort of however we will see later on, but some Stewart equations, some particular Stewart equations applied as we know with the constant acceleration. Okay, constant acceleration is straight line at body at time t. The body is at distance s from its rest position. Okay, time t, the body is at distance s from its rest position. A graph is drawn s against t square as shown in the figure. Okay, so they are asking that which statement describes the acceleration of the body. Either it is equal to half the gradient, equal to gradient twice of the gradient of this graph given, or reciprocal of the gradient given. Okay, so it means somehow we need to find the relation between acceleration, okay, and the gradient of this graph. Acceleration and the gradient. Acceleration and gradient. Acceleration and gradient of this graph. Okay, so how we find a gradient in mathematics? We know, in physics we know that if you are given with such a line, say that let's suppose this is a straight line. Okay, y-axis here and x, you know, and what will be the gradient? The gradient, you know that it is basically, here it means that the gradient will be nothing but the gradient is y upon x. Just note this point carefully. Gradient of the graph in a straight line is y upon x. All the values of y, or the change in values of y divided by the change in value of x. Okay, change in value of y numerator and change in value of x in the denominator side. Okay, likewise the same here. If we come to this graph, we will say that the gradient of this graph is y upon x, means here the y is x and here on x axis it is t square. So in place of y we will write s, and in place of x we will write t square. Okay, so this will be the gradient of this graph, but somehow we need to relate this s upon t square with acceleration. Okay, we need to relate this s upon t square with acceleration, and then we can only say that either acceleration is half or double or equal to or reciprocal to this s upon t square or the gradient. Okay, so here we know that using Stewart equations we have some formula for s equal to u t plus half ut plus half a t square. Okay, it is for uniform acceleration, as we know that in the question uniform acceleration is given, uniform constant acceleration, so that's why we are using this equation. Okay, so as you know that the body, the statement describes that initial body move from rest, so therefore the initial velocity is equal to 0. Okay, so this will be s equals half a t square. Okay, and we want to find s upon t square. Okay, we need to find this because we need to find a gradient, so we need to find s upon t square. So this will be s upon t square equals, okay, a we keep on the left hand side, right hand side, and 2 towards the left. Okay, so A is equal to 2 upon 2 into s upon t square. We know that s upon t is the gradient, so it means that acceleration is equal to twice of the gradient. S upon t square is our gradient. Okay, so just check the option. Acceleration is equal to twice of the option part C. Okay, so part C will be the correct answer. Acceleration is equal to twice of the gradient of this graph. Okay, so I hope you get the solution. If you have any question or any queries, do let me know. Thank you. Like and do not forget to like and subscribe my channel for A-level physics and for A-level mathematics.